In case if there is an error, beep actually returns back a result, and this result can be analyzed by our program. So if it succeeds, it returns a non-zero value. Otherwise, it returns the 0, and the error code can be retrieved by calling getLastError. That's another Windows API call. So we can now try to use calling beep from assembly. So let's clean this solution and close it. And then we can load our recent project, which is M09, and continue with testing the code related to this beep. So in fact, what I'm going to do is that instead of copying and pasting everything into the main procedure, I would like to use a separate procedure, which is a very simple idea. I can just say make beep, right? Make beep, and say that this is my procedure. So assembler requires that we use end procedure to mark the ending of the procedure. And of course, the last statement here will be a return statement like this. Now, I'd like to say that I would like to make it so that to call this procedure, pass frequency in let's pick EAX, and register EAX, and duration in register EBX. Let's just pick a couple of registers, and so we will use these to register to pass these parameter frequency and duration. Okay, so now it's important to know something about the beep, is that beep actually can be called through this symbol. And let me explain what this is. We can call beep like this. So this is a calling convention name decoration, because this is a Windows API call. Most of them are using standard calling convention, and this specific calling convention decorates the name of beep. We've seen the beep to have this name, but it's using the underscore in front of it, and also the @ sign, and then followed by the number of bytes of the parameters that the beep is using. So this symbol has to be declared, and we need to declare it as just by saying that we're using this external symbol. Okay, and this is the symbol which is available directly in our memory segment, which is specified by this near qualifier. Right, so this is a near type symbol that's is helping assembler to generate the appropriate call. Now we also know that the beep call requires two parameters, and so we're going to specify parameters on the stack as push EAX, actually EBX first, and then push EAX. So this will be our duration, and this will be our frequency. So this is also part of the calling convention, and so besides prefixing the underscore and the suffix, the arguments are passed on the stack right to left order. So basically, if we use this type of syntax in our C program, so we essentially specify frequency and duration in this order right here when we make a C call. So those parameters have to be provided to the actual call, this API call, in the right to left order. So basically we pass duration first and then frequency, and this is why the parameters are passed on the stack, and the first parameter should be EBX and then EAX, which correspond to duration and frequency. So this is how we can call it. Now also what is very important is that the Windows API calls do not protect the registers. So if we want to protect our registers, what we need to do is we'll just push all of our general purpose registers, the double word registers. So push all double word registers. Okay, so we're going to preserve all registers as a first step in our program right here. And before we return, we will restore okay, let's do pop AD, and this will restore all general purpose registers. Okay, so this is going to be preserving and restoring them. Then we can also perhaps what we can do is we can also call sleep later on to kind of synchronize all of this, but let's just make this one single beep in this demonstration. All right, so I'll keep this sample for now, and before we return, I'm just going to call make beep, and now we can load these values that we just got from our C++ sample. Right here we can, for example, start with the first sound and specify that the frequency is 500. Right here, so we're just going to say move into register EAX 500, and this is specification for frequency, and we will load register EBX. Also 500 we can use, and this will be the duration. Right, so this duration is 500 milliseconds, and the frequency is 500 Hertz. Okay, so this should be our demonstration for making a single beep on this system. So we'll try building this. And I'm getting a linker error here because I placed this extern incorrectly. It needs to appear after the model, I believe. So we can place it right here and build again. Okay, so this time it's all fine. So I'll just press Ctrl F5 to try to generate a sound. Okay, so I hope you could hear it in my recording. And so this is our demo for basically calling beep with the special decorated name. And also this is our little procedure that's taking EAX and EBX as inputs. We preserve all of our registers and we restore all of our registers before we return from this procedure. And we use EBX and EAX on the stack like this, and this is how the parameters are passed to the beep on the stack. And we just specified that both frequency and duration should be provided by these two registers. And then we just make a call into our procedure, and it's really not that difficult to create a small procedure like this in assembly program.